Welcome to the channel, everyone. Today we're tackling a topic that's super relevant whether you're just starting out in the programming world or you're a seasoned pro looking to level up object-oriented programming interview questions. We're going to break down 10 of the most common OOP questions you might encounter, and trust me, these come up more often than you think. We'll dive deep into each concept, make sure you really understand the why behind the answers, and arm you with the knowledge to absolutely crush your next interview. No more stressing about those curveball technical questions. Let's get you feeling confident and prepared. Stick around because by the end of this video, you'll be well on your way to acing those interviews and landing that dream job. Let's get started. All right, let's kick things off with the foundation of OOP, the 4 pillars. These are like the fundamental building blocks that make OOP so powerful, and there's something interviewers love to ask about. We're talking about encapsulation, abstraction, inheritance, and polymorphism. Think of encapsulation like a protective shield around your code. It's all about bundling data and the methods that operate on that data within a class, kind of like a self-contained unit. This helps prevent accidental data modification and promotes code organization. Next up, abstraction. This is all about simplifying things for the user. Imagine you're using your phone. You don't need to know how the touchscreen technology works at a granular level, right? You just interact with the simplified interface. That's abstraction. Hiding the complex implementation details and presenting a clean, easy-to-use interface. Now, inheritance. Think of this as code reusability at its finest. With inheritance, you can create new classes, child classes, that inherit properties and methods from existing classes, parent classes. This saves you from writing redundant code and allows you to build upon existing functionality. Finally, we have polymorphism, which literally means many forms. In the OOP world, it means that objects can take on different forms while still responding to the same method calls. Think of it like a button. It can be clicked, tapped, or even voice activated, but the underlying action is still the same. Pretty cool, right? Understanding these 4 pillars is key to grasping OOP as a whole. Interviewers want to see that you not only know what they are, but that you can also explain them clearly and concisely. Now, let's dive into a classic OOP interview question that often trips people up: the difference between overloading and overriding. Don't worry, it's not as complicated as it sounds. Overloading is like having multiple methods in the same class with the same name, but they have different parameters. Think of it like ordering a pizza. You can order a large pepperoni, a small cheese, or even a medium veggie. Same action, ordering a pizza, different ingredients, parameters. Overriding, on the other hand, happens when a subclass provides a specific implementation for a method that's already defined in its superclass. Imagine you have a base class called animal with a method called makeSound. You then create subclasses like dog and cat. Each subclass would override the makeSound method to produce their specific sounds. Here's a key difference. Overloading happens within the same class, while overriding involves a subclass and its superclass. Interviewers might try to trick you with this, so pay close attention to the context of the code example they give you. Understanding the distinction between overloading and overriding demonstrates a solid grasp of OOP principles and how methods work within a class hierarchy. Remember, clear and concise explanations are key to nailing those interview questions. Let's move on to another fundamental concept that interviewers love to test: the difference between a class and an object. This is one of those OOP basics that you absolutely need to have down pat. Think of a class as a blueprint. It defines the structure, behavior, and properties that objects of that class will have. For example, if you were creating a car class, you'd define attributes like make, model, and year, as well as methods like start engine and apply brakes. An object, on the other hand, is an actual instance of a class. It's like taking that blueprint and using it to build a real car. So you could have multiple car objects, each with its own unique set of values for the attributes defined in the car class. Here's an analogy. Imagine a cookie cutter. The cookie cutter itself is the class. It defines the shape and size of the cookie. Each cookie you cut out using that cutter is an object, an instance of the cookie cutter class. Interviewers want to see that you understand the difference between the blueprint and the actual thing built from that blueprint. Remember, a class defines the structure, while an object is a specific instance of that structure. Now let's talk about this keyword, a small word with a big role in OOP. Interviewers often bring this up to gauge your understanding of object context within a class. In essence, this acts like a reference to the current object within a method or constructor. It's like saying, hey, I'm talking about specific instance of the class right now. One common use of this is to differentiate between instance variables and parameters that have the same name. Imagine you have an instance variable called name and a constructor parameter also called name. Using this .name would refer to the instance variable, while name alone would refer to the parameter. You can also use this to pass the current object as an argument to another method, or even return the current instance from a method. It's all about maintaining that clear reference within the object's scope. Understanding the role of this demonstrates a deeper understanding of how objects interact and maintain their state within a program. Don't underestimate the power of this little keyword. It can make a big difference in your code. All right, let's talk about abstraction, but this time, we're diving into the world of abstract classes and interfaces. These are powerful tools in OOP, and they often go hand in hand, but there are some key differences that interviewers love to ask about. Think of an abstract class as a sort of blueprint for other classes. It defines a common set of methods and properties that its subclasses must implement, but it can't be instantiated directly. It's like saying, here's a template for a car, but you can't drive this template, you need to build a specific car from it. Interfaces, on the other hand, take abstraction a step further. They're like purely abstract classes where all methods are abstract. An interface defines a contract, a set of methods that any class implementing that interface must provide. It's like saying, if you want to be considered a vehicle, you have a start and a stop method. Here's a key difference. A class can implement multiple interfaces, but it can only inherit from one abstract class. This highlights the difference in their intended use. Interfaces define capabilities, while abstract classes provide a common base implementation. Understanding the nuances of abstract classes and interfaces demonstrates a strong grasp of OOP design principles and how to create flexible and extensible code. Let's shift gears and talk about constructors, those special methods that play a crucial role in the lifecycle of an object. Interviewers might ask about constructors to assess your understanding of object initialization and setup. Think of a constructor as a setup crew for your objects. It's a method that gets called automatically when you create a new object of a class. The constructor's job is to initialize the object's state, set default values for its attributes, and essentially get it ready for use. Constructors have the same name as the class and don't have a return type, not even void. They can be overloaded just like regular methods, meaning you can have multiple constructors with different parameters to handle different initialization scenarios. Why are constructors so important? Well, they ensure that your objects are born in a valid state. Imagine trying to drive a car without an engine. Not a great experience, right? Constructors make sure that all the essential components of your object are in place from the get-go. Understanding the purpose and mechanics of constructors is fundamental to working with objects effectively. It shows that you care about creating robust and reliable code, which is something every interviewer looks for. Let's talk about one of the coolest features of OOP, polymorphism. It's a concept that often comes up in interviews, and for good reason. It's all about making your code more flexible and adaptable. Polymorphism, in simple terms, means many forms. In the context of OOP, it means that objects of different classes can be treated as objects of a common superclass. This allows you to write more generic code that can work with a wider range of objects. There are two main types of polymorphism: compile time, also known as static, and runtime, which is dynamic. Compile time polymorphism is achieved through method overloading, which we discussed earlier. Runtime polymorphism is achieved through method overriding, where a subclass provides a specific implementation for a method defined in its superclass. Think of it like this. You have a shape class and subclasses like circle, square, and triangle. Each subclass overrides the draw method to draw itself correctly. With polymorphism, you can have a collection of shape objects and simply call the draw method on each one. The correct implementation will be called based on the actual type of object. Polymorphism is a powerful tool that allows you to write more reusable, maintainable, and extensible code. Now let's talk about something that's not just a single concept, but a set of principles that can elevate your OOP game to the next level: the solid principles. These 5 principles are like guidelines for writing cleaner, more maintainable, and more robust object-oriented code. Interviewers might ask about them to gauge your understanding of good software design practices. Let's break them down quickly. Single responsibility principle. Each class or module should have only one specific responsibility, making it easier to understand and modify. Open-close principle. Software entities like classes and modules should be open for extension, but closed for modification. This means you should be able to add new functionality without changing existing code. Liskov substitution principle. Subtypes should be substitutable for their base types without altering the correctness of the program, ensuring that inheritance hierarchies are used correctly. Interface segregation principle. Clients should not be forced to depend on methods they don't use. It's better to have smaller, more specific interfaces. Dependency inversion principle. High-level modules should not depend on low-level modules. Both should depend on abstractions. Understanding and applying the solid principles can significantly improve the quality and maintainability of your code, which is something every interviewer appreciates. Let's dive into a topic that's all about relationships: composition versus inheritance. These are 2 fundamental ways to relate classes in OOP, and interviewers often ask about them to assess your design skills. Inheritance, as we discussed earlier, is about creating an is-a relationship between classes. A subclass is a type of its superclass. For example, a dog is a type of animal. Inheritance promotes code reuse, but can lead to tight coupling between classes. Composition, on the other hand, is about creating a has-a relationship. One class has an instance of another class as a member. For example, a car has an engine. Composition offers more flexibility and promotes loose coupling between classes. Think of it like this. Inheritance is like inheriting your parents' traits, while composition is like building a car by assembling different parts. Both approaches have their pros and cons, and choosing the right one depends on the specific scenario. In general, favor composition over inheritance unless there's a clear is-a relationship. Composition tends to lead to more flexible and maintainable code. And finally, let's wrap things up with a topic that often trips people up: shallow copy versus deep copy. This is a question about how objects are duplicated, and it can have significant implications for your code's behavior. Imagine you have an object that contains other objects as members. Now you want to create a copy of that object. This is where the distinction between shallow and deep copy comes in. A shallow copy creates a new object but simply copies the references to the nested objects. This means that both the original object and the copy will still point to the same instances of the nested objects. A deep copy, on the other hand, creates a completely independent copy of the object and all its nested objects. This means that any changes you make to the nested objects in the copy won't affect the original object. Think of it like this. A shallow copy is like photocopying a document. You get a new copy of the paper, but any writing on the original will still be visible on the copy. A deep copy is like retyping the entire document. You get a completely independent copy. Understanding the difference between shallow and deep copy is crucial for avoiding unexpected behavior in your code, especially when dealing with mutable objects. And there you have it. 10 of the most common OOP interview questions answered. We've covered a lot of ground today, from the 4 pillars of OOP to the nuances of shallow and deep copy. Remember, the key to acing those interviews is not just memorizing answers, but truly understanding the concepts behind them. Practice explaining these concepts in your own words, and don't be afraid to ask questions if something is unclear. If you found this video helpful, hit that like button and subscribe to the channel for more tech insights and interview tips. Good luck with your interviews, and I'll see you in the next video.